right, this is section, well, actually, I don't even want to say section number. We're just doing surface area pyramids today. That's how you're going to find this video. So let's first talk about pyramids and a couple of vocab words about them. They have two different types of height. They have a height that is straight up the center of the bottom of the pyramid, straight to the top. That is what we just call height. Then we have a height that follows the outside edge or the outside face of this pyramid, and that is called the slant height because it is at a slant. What's interesting is when you connect the bottom of this, it makes you a right triangle, which is nice, so we're to be able to do Pythagorean's theorem. What you also want to know is that when you do that, since this is at the very center of the bottom, when you draw it out to the edge, it's only going to be half of the whole side. So that is exactly halfway in the middle. So when you draw that triangle, we'll do one of those today. This is half of the whole side length, okay? So let's go to our formula card. Let's talk about all of the different types of pyramids that we're going to be doing the surface area of. I'm just kind of blocking out the others so that you get focused on just the ones we're going to be doing here. These are the volumes. Don't pay attention to that. But these are the three we're going to be doing. We've got our triangular pyramid, our rectangular pyramid, and then our n-gon pyramids. Let me just do this just so we stay focused. Okay, so all of our pyramid formulas are actually the same, kind of like our prisms. They have a capital B, which is area of the base, the bottom, and then 1/2 PL. So 1/2 the perimeter times the slant height. That's that height we just talked about. It kind of goes along the outside of the picture. To separate these into the three different kinds, I'm just going to be replacing the B with its actual base formula. So this first one is a triangular bottom, and the area of a triangle is 1/2 base times height. So that is of the bottom, and then you've got 1/2 the perimeter times the slant height, and perimeter is at NSL, so number of sides times side length, and then slant height. So this is the generic formula, and this is kind of broken out to each of its pieces. Next up, we've got the rectangular bottomed pyramid. So the base of that, since it's a rectangle, will be base times height. And remember, this is of the bottom. That's why I wrote that there, so you don't forget. Some kids will see the H and you'll try to do the regular height, but we're just talking about the base and height of the bottom of the pyramid. And then 1/2, and it's perimeter times slant height, and perimeter is just number of sides times side length, so that's NSL. Last one is your n-gon. So on the bottom, that formula is 1/2 ANS. That's just your bottom. And then you've got a half, and then the NSL formula. So kind of, they all have that same structure, area of the base plus 1/2 PL. Let's try a couple. First one has a regular square pyramid. So square means that every edge on the bottom is the same. So this is 16, that's 16, 16, and 16. I meant to use a pen. Okay. Then they're telling me my slant height is right here. You can kind of see where it's pointing. They're telling you that the regular height is 15. And then they're trying to, this should say 1/2, it's kind of blurry, but they're just pointing that this is half of the base, so half of this 16. And they're telling you the base age is 16, sorry, and then find the surface area of the pyramid. So surface area equals, and I like to write out the formula so I know what parts I need to go find. So I am looking at this one, I'm looking at this formula, so area of the bottom plus 1/2 NSL. So area of the bottom, oops, I shouldn't have made that. I just wanted to write bottom. And then 1/2 NSL. So on the bottom, it is a square. And one edge is 16. That means they're all 16s. And the area of this would then be 16 times 16. 1/2 NSL, the number of sides on the bottom is 4. Side length is 16. We already talked about that. And then slant height is what I don't have. I have regular height, but I do not have slant height. So I'm going to draw that triangle right over here just to get a look at it. 15 is my regular height. Slant is what I don't know. And then my base, remember the whole thing is 16, so we're just using 8. This is where my 90 is, so my slant height is my hypotenuse. So I have 15 squared plus 8 squared. Putting those together, I get 289, and then we're going to square root that. So I get 17 is my slant height. So I'm just going to drop that in the formula, and now we're just typing all that in. So it's 16 times 16 plus 0.5 times 4 times 16 times 17. Looks like my surface area is 800 centimeters squared. Next up, they want to find the surface area of a regular hexagonal pyramid. So it just means on the bottom that all of the sides are the same. So they're all 10s on the bottom. So surface area formula for this is going to be 1/2 ANS and then 1/2 NSL. So I'm just copying that right off my card. So first up is 1/2 apothem. I'm looking for the segment that goes from the center to the middle of the side. And they're telling me that's 5√3. So just some decimal when I type that in my calculator. And as number of sides, I have 6, and side length is 10. So they gave me side length right there. Next up, I've got 1/2 number of sides is 6, side length is 10, and I need slant height. Oh, they gave me that too. So there's a 14 right there. That is my slant height. Now I just get to type all of this in. So I've got 0.5 times 5√3. Don't be scared of that root. It's just going to make a decimal. Times 6 times 10 plus 0.5 times 6 times 10 times 14. So it looks like my surface area is about 679.8 feet squared. Last one, it says find the surface area, but be careful. What kids usually forget about surface area is that you're talking about the edges that need to be painted. Or if you were to wrap this as a present, where would you wrap it? And it's easy to kind of look at those two formulas and go, well, I'll just add them together. But what's tough about surface area is anywhere they overlap, we wouldn't technically paint. We wouldn't wrap in between here where these two meet. So we can do the two formulas, but we also have to take out, we have to subtract anything where they overlap. So I'm going to take my square-based, and I hope you have marks on here that I marked this before I made copies, but these should all be the same. So this is a cube on the bottom. Everything's an 8. So I'm going to take that surface area formula, which is 2 times, and then it's each of the sides matched up once where they kind of date each other. But since it's a cube, it means all of these are the same. So I'm just going to do 6 of those sides, and they're all going to be 8 by 8s since all of these sides are the same. Plus, that's for the cube. Now we need the pyramid. The base of the pyramid is a square, so it's going to be base times height, so 8 times 8. And then I need 1/2 NSL. So number of sides is 4. Side length is 8. And slant height I don't have. So we're going to have to go find that. Here's my triangle, 5, and then 1/2, and then my slant. So I'm just going to draw that right here. I got a 5. I got my slant, which I don't know. And then this side is 8, but we're only going to use half of that, so 4. So my slant height equals 5 squared plus 4 squared, which is 25 plus 16. So my slant height is square root of 41. Whatever that decimal is, it's fine. We just wanted to be able to plug it in here, so square root of 41. Now the trick is we have to take out where they overlap. And the cube, if I could like separate these two, the cube overlaps on the top of it, and the pyramid overlaps on the bottom of it. So that shape where they're overlapping is a square. I know the area of a square is just base times height. So for us, it's 8 times 8. And there are 2 of those I need to subtract. I need the top of the cube taken out, and I need the bottom of the pyramid taken out. So here's 2 different ways you could do it. I could just do, I'm going to minus 2 of the 8 times 8s. That's my overlap. That's my top of the cube, bottom of the pyramid. You could have also come back here and just maybe made that a 4 instead. Just take the 2 of them off of right there. You could have cut this out because that's the bottom of the pyramid, and just change this to a 5 because you only would have used 5 sides of the cube. So lots of different ways to do it. I just have it written at the end with a minus 2. So I've got 6 times 8 times 8 plus another 8 times 8 plus a 0.5 times 4 times 8 times root 41. And then I'm going to minus 2 of the 8 times 8s. Equals, so it looks like I got about 422.45 excuse me, centimeters squared. So those are your pyramids. Keep track of whether or not you have real height or slant height. It usually just requires a little Pythagorean's theorem of you. And then watch where you're overlapping if you have 2 shapes coming together so you don't overcount.